Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on errors. So, suppose an automobile manufacturer advertises that its new hybrid car has a mean gas mileage of 50 miles per gallon. So they're telling me, hey, we have a claim of 50, so 50 mpg. You represent a consumer advocacy group that believes that the mean gas mileage is less than advertised. You take a simple random sample of 35. So I'm just going to start writing this down. Mean 50 miles per gallon. N is 35. And test their gas mileage out of the more than 50,000 hybrid cars. Well, we can see that that's definitely less than 10% of the population. You find that the sample has an average. So the sample average, or the X bar, is 48.3. And a sample standard deviation of 5.7. Test at a significance level of 0.05. So alpha, I'm going to go ahead and write that right here. Alpha is 0.05. To determine whether there is a significant evidence indicating the cars get fewer miles per gallon. So we're looking again for fewer. They indicated up here that it was less, so that's not a surprise than is claimed by the manufacturer. So our hypothesis is as follows. The null mu equals 50 miles per gallon. We can't disbelieve until we find out otherwise. We always goes with the claim, and this will always be equal. The alternative, or the ha, mu 50 miles per gallon. This part will always be the same, but in this case, they wanted to know if it was less or fewer. So this will get a less than sign. I'm going to go ahead and write my formula. Squeeze this in right here. And we have T equals X bar D minus mu D SD divided by the square root of N. And I'm going to plug in. And I have T equals 48.3 was my X bar minus the mean of 50 over the standard deviation of 5.7 divided by the sample size of 35. So let's take a look at this and run this real quickly. So stat test, T test, 50 miles. 50 miles is the claim. 48.3 is what we found from the sample. 5.7 was our standard deviation. There's our sample size, and we have less than highlighted. But when I calculate, I end up getting a T equal to 1.764. So the probability that T is less than negative 1.7644 equals a p-value of 0.0433. 0.0433. Make these the same length. And 433 is definitely less than 500. So our decision is to reject the null. Now we skipped a bunch of steps that would have been required, as in showing our conditions, defining our parameter, writing our conclusion, but that gives us a good start as to determining the type of error. So based on our decision up here in the hybrid, what type of error was committed? Well, let's talk about that real quickly. We don't know if an error was committed because errors happen by random chance alone. Basically, you took a sample and for whatever reason, you took the sample correctly, but your sample did not match the population. You put everyone's name in a hat and you drew too many freshmen, or you didn't draw enough seniors. Whatever the case may be, you mixed it up, you did everything correct, and you got a sample that wasn't represented. So that's the type of error. So you don't know if an error was committed. So it will never be a type 1 was committed or type 2 was committed without further information. Just based on running the test, we might have committed an error. So it'll never be one of these based on without more information than what we have. So we might have committed an error. Well, since we rejected the only type of error The only type of error that we may have committed is a type 1. If you reject, you might have committed a type 1, fail to reject, fail to reject, you might have committed a type 2. All right? Well, we rejected, so the only type that we could have committed, the only type that we could have committed is a type 1. All right, so a type 1 may have been committed. The next thing says no errors could have been committed because the test was run properly. The test was run properly. If you check the conditions, all the conditions were met, everything was done correctly. But still, when you take a sample, it is possible that your sample will not represent the population. All right, does not match it. Okay, and that's called, because this is back to sampling error. So this is type 1 sampling error, not a mistake was made. So referring to the scenario above, explain the consequences of committing a type 1 error. All right. So in this case, I'm going to go back to my null and alternative. Well, my null was the company claimed that it was 50 miles per gallon, and we believe that it was less than that. So I'm going to write this down. HO mu equals 50 miles per gallon. The alternative, mu is less than 50 miles per gallon. Well, we committed a type 1, so we rejected HO and we believe HA, but we rejected HO, and remember this is an error in error. So let's write that up. Because remember, if you just put this down, that's not enough information. You've got to explain it and you got to give the consequences. We rejected the null, so the only type of error that could be committed is a type 1. In this case, the company is producing hybrids that get 50 mpg, but we made, let's not say made, but we believe that they are producing hybrids that get less than 50 mpg. So we wrongly sue, because that's all we always do, the company for false advertisement. All right, so because we believe that they're producing cars that get less than 50 miles per gallon, we sue them for false advertisement. Or we go out and write an article saying, hey, they're liars, they're not producing cars with 50 miles per gallon. but they actually were, because the type 1 error says we rejected a true null. The true null is, hey, they're producing cars that get 50 miles per gallon, but we rejected that and we believe this. All right. So, um, in this case, what is power of the test? Well, as a reminder, power is correctly rejecting a false null. In this case, we reject the company's claim that they are producing cars that get 50 mpg, and we are correct. So we correctly rejected. In other words, we rejected and we were supposed to. They really are making cars that are less than 50 mpgs. All right. So in this case, hey, we did reject. If that is true, if they really are making cars less than 50 mpgs, we did the right thing. And power is, hey, um, in this case, and power is correct. And it should say, I left something out really important, is the probability that we would correct. In this case, it would be the probability we reject the company's claim that they are producing cars that get 50 miles per a gallon, and we are correct. So power is the probability of correctly rejecting a false null. Power is the probability of correctly rejecting a false null. Sorry, you can't read that, but its power is the probability of correctly rejecting a false null. In this case, the probability we reject the company's claim they are producing cars that get 50 miles per gallon, and we are correct in rejecting their claim. Yeah, they claimed it, but it wasn't true, and we rejected. We did the right thing. All right, thanks for watching. I hope this helped.